back again. This is the last part of chapter 2, whole number. In this video, we will be discussing the section 2.4, which is properties of whole number. Let's see what properties are we going to discuss. We are going to see about the closure property, the commutative property, the associative property, and last, we'll see the distributive property. So let's start. Chapter 2, whole numbers. So our agenda for today will be completing the section 2.4, which is property of whole numbers. Our first property is the closure property. A closure property is a very easy and simple property. So what does the closure property say? It says that if you have any two whole numbers and if you add or multiply them, the sum or the product should be a whole number. But here in the closure property, we have an objection. The subtraction and division side. There might be some chances that when you subtract or divide, the number may or may not be a whole number. Why? Because sometimes if you subtract or divide, the number can come in decimal, fraction, or the negative side. So they are not whole numbers. Let's see some examples. 7 plus 8, which is 15. So this is a whole number. As we said before, if you add or multiply any two whole numbers, it will always result as a whole number. 5 plus 5, which is 10, and 10 is a whole number. I'm sure you know what are whole numbers, and if you don't, let's do a quick revision. Whole numbers are the numbers which start from 0 till the infinity. If you want to know more about the whole numbers, you can check out my previous video on this lesson. Our next example is 0 plus 15. So this gives us 15, which is also a whole number. And the examples I'm telling you right now are from the book, so you can also check them there. Let's see some examples on the multiplication side. 7 into 8, which gives us 56. 56 is a whole number. Next example is 5 into 5. 5 into 5 gives us 25, which is also a whole number. And 0 into 15 is 0. Why? Because if you multiply any number by 0, the result will always come out as 0. And 0 is a whole number because all the whole numbers start from 0 till the infinity. Let's see the subtraction and the division side. 6 minus 2, 4. It is a whole number. As we said before, it may or may not be true. Sometimes it can also be true, like in this case. Let's see our next example, which is 7 minus 8. What is the answer? It is minus 1. And minus 1 is not a whole number because it is a negative number. Next we have 5 minus 4, which is 1, and 1 is a whole number. Our next example on the subtraction side is 3 minus 9. What is the answer? It is minus 6. So it is not a whole number. Let's see some examples on the division place. It is 8 divided by 4, which gives us 2. And 2 is a whole number. 5 divided by 7. So as 7 will be outside, it is known as the divisor, and 5 will be inside, and the 5 is a dividend. Now, when a bigger number is outside as a divisor, we need to put a point if a smaller number is inside. Otherwise, we cannot divide. So here we have put a point and got a 0. And we all know 7 sevens are 49. So we got our remainder as 1. We can divide further, but we already know that this answer is going in decimal, so it will eventually not be a whole number. Now I want to tell you one thing. Let's suppose we have this number, which is 1.3. And we consider this as a decimal number because it is. But the thing here is the 1 is not a decimal number. It's a whole number because it is before the point. But 3 is not a whole number because it is after the point. But this number will be considered as a decimal number, and we cannot write 1 as a whole number here and 3 as a decimal number there. We'll write this whole thing as a decimal number and it will not be a whole number. Okay, let's move ahead. Commutative property of addition and multiplication. Commutative property states that the change in the order of number in addition or multiplication operation does not change the sum or the product. What does this mean? This means if we have two numbers and if we need to add or multiply them, we can put them in any order. Let's suppose we have two numbers. What number should we take? Let's take some small numbers to start with. We can take 5 and 7. So we have written 5 into 7. We can also write it as 7 into 5, but this won't change our answer. In both the cases, our answer will be 35. So let's understand this via some examples. Here we have 345 plus 876, which gives us 1221. Now if we change the order of these two numbers, we get 876 plus 345. But surprisingly, our answer remains the same. Why? Because it's addition. Or if we also do multiplication, our answer will remain the same. How? Let's see. 129 into 38, which is 4902. And if we want to speak it in a numeral form, it will be 4902. Next we have 38 into 192. It's just reversed. These numbers are reversed. Instead of putting 192 into 38, we have put 38 into 192. And our answer is still the same, which is 4902. But this does not apply if we do subtraction or division. Why? Let's see. If we have this number such as 7 minus 3, what will be our answer? It will be 4. But if we change the order of the numbers and we put 3 minus 7, we will get minus 4. They both aren't same. This is a positive number and this is a negative number. And the same thing applies with division. Associativity property of addition and multiplication. This property states that when numbers are added or multiplied, the sum or the product is the same regardless of the grouping of the attendant. So let's understand this via some examples. Here we have 7 plus 54 plus 90. So first we will add these two numbers, and then what we'll get adding these two numbers, we'll add 7 to it. And our total answer will be 151. And the other way of grouping can be 7 plus 54, our answer, and then we add 90 to it. Our answer still remains 151. So our next example is 45 into 10 into 100. So our final answer will be 45,000. Why? Even if we change the order of grouping, the answer still remains the same, but it should be addition or multiplication. It doesn't matter how you put it. Last time we saw that I just removed the bracket from here and put 7 and 54, but this time I moved the number also. So 45 into 100, what does this give us? It gives us 44,500, and if we add 10 to it, our final answer will be 45,000. See, our answer still remains the same. Next we have 90 into 30 into 20. Our final answer will be 54,000. And if we change the order, 90 into 30 into 20, our answer still remains the same, which is 54,000. Now there is a thing which we all know, that division by 0 is not possible. So how much hard you try, that you will never be able to reach your answer if you do division by 0. We can also say that division by 0 is not defined. So what is our next property? Let's see. It is distributivity of multiplication over addition. This sounds fun. So, the distributive property states that multiplying a sum by a number gives the same result as multiplying each addend by the number and then adding the products together. So, what does this mean? Let's understand via this table I have made. So here I have took a number and then we will solve it by the common way and the distributive property way. So common way will be using BODMAS. In BODMAS, what we do, we solve the brackets first. So when we have solved the bracket, which is 30 plus 10, which gives us 40, and then if we have no sign after completing the bracket, this means that we need to multiply. Then we multiply 24 into 40, which results as 960. So this was the common way, which most of the people do. Now let's see the distributive property way. We have took the same example and now let's do it in a distributive property manner. Here, instead of adding these two numbers first, we will work with the number outside, which is 24. And now we will multiply all the numbers inside the bracket with 24. First, we multiply 24 into 30. And then we multiply 24 into 10. And our numbers, our answers or our products, whatever you say, we will add both of the products together to get our final answer. Surprisingly, it's the same, 960. But remember, this only works with addition and multiplication, not with the subtraction and division. Hope you enjoyed my today's video and learned something new about the properties of whole numbers. If you have not checked out my previous video on this chapter, you can find the link up right in the card or down in the description box. Till then, I'll meet you in my next video. It will be the chapter 3